Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject microprocessor, microcontroller and interfacing techniques. We're going to see operation modes of 8254 in this video. In previous video I have already explained the architecture of 8254, the pin diagram of 8254, what is the purpose of 8254. I would recommend you people to go through that video so that you can easily understand the operation modes of 8254, right? So before starting with operation modes of 8254, I'll just to refresh the basic concepts of 8254. We know that 8254 is a programmable interval timer and it is used to create infinite delay for microprocessor and microcontroller. And I already explained in architecture that it has three counters, which is counter 0, counter 1 and counter 2. All are 16-bit counters. For each counter, you will have two inputs and one output. That is, clock and gate will be the input and output signal out 0 will be the output for counter 0. Similarly, you have two input signal and one output signal. Two input signal and one output signal. And we already seen what is the use of data bus buffer, control register and read-write logic, right? So here, for understanding the operation modes, you have to understand how is that we have to configure the control word register, which I have explained in previous video. Please go through it, right? So in order to configure the control word register, right, you can see this particular control word register of 8254. So I'll just give you the overview of it, where this bit will tell you whether the input is going to be BCD or the binary. That is, 8254 accepts both binary and as well as BCD, where this particular bit tells you whether it is going to accept BCD or binary form. And these three bits, D1, D2, D3, which selects the modes of operation, which tells you which mode of operation that is going to happen, right? So you can see from mode 0, mode 1, mode 2, mode 3, mode 4, mode 5, we have 6 modes of operation. And I've already explained these two things about read-write operation, right? Read-write operation about which byte, lower byte or upper byte, right? The least significant byte or most significant byte, right? And these two bits tells you which counter. We already know that we have three counters, counter 0, counter 1 and counter 2. And this tells you which counter that is going to be get selected. If it is 0, 0, it is counter 0. And if it is 0, 1, it is counter 1. And if it is 1, 0, it is counter 2. So if you want to know in detail about this configuration, please go through the previous video, right? As of now, you understand the modes of selection is obtained from these three bits and counters is selected depending upon these two bits, right? And as I said, we have 6 different modes, and you can see here the 6 different modes of mode 0, which is called as interrupt on terminal count, and mode 1, which is hardware read triggerable one shot, and mode 2 is rate generator, and mode 3 is a square wave generator, and mode 4 is software triggered strobe, and mode 5 is hardware triggered strobe. It is very important you have to understand the timing diagram of all these modes, right? And before going to that, you have to understand that each and every counter, say for example, if you take counter 0, you have clock signal and you have gate signal as input, and then you have one output signal, right? And now in these modes, this will act as a rate generator, this will act as a square wave generator, and this will create a software triggered strobe, and this will be acting as a hardware triggered strobe, right? And these modes of selection can be obtained from those 3 bits, that is M0, M1, M2, D1, D2, D3, right? This will tell you which mode is going to be selected. That is 8254, like which mode it's going to operate. That is be decided by M1, M2 and M3. Right. Similarly, the last bits D6 and D7 determines which counter it is going to have. It is going to be selected. Right. Now, this gate signal and clock signal, that is going to be input. Right. And for all the modes except mode 1 and mode 5. mode 1 and mode 5, right? Except these modes, for all other modes, gate signal will be high. Gate signal will be high, which means this gate signal is the one. Clock signal is normal input, where for all the modes of operation you will have clock input, right? And all these counters, counter 0, counter 1, counter 2 are down counters. What is down counters? Say for example, if you're going to give the count value as 10, right? And as soon as the counter starts, it will automatically decrement for every clock cycle. That is, it will go to 9, 8, right? 7, 5, 6, and it will go up to 0, right? This is how the counter works, right? And you will have a normal input signal, that is clock signal, and this gate signal will be normally high. Only if the gate signal is high, the counter will start decrementing. The counter will start functioning, right? So for a counter to work, you should have a clock input, and also the gate should be set high. So gate signal is the one which sets the counter, that is which enables the count value and disables the count value, right? So if gate signal is 1, only then the counter will start working, right? It will start decrementing, right? So for all the inputs, for all these modes, for mode 0, mode 2, mode 3 and mode 4, gate 1 will be 1 and clock signal and followed by the clock signal, right? For every clock signal, the gate signal will be 1, so that as soon as you load the count, then the counter will start decrementing, right? But whereas here in mode 1 and mode 5, right, here the gate signal will be used as a trigger pulse. It will be used as a trigger pulse. That is, it will start the count value only at the rising edge of the pulse, right? So only for the rising edge it will happen. Like say for example, if this is the pulse, then only at this rising edge it will start the count value. It will start the counter. Whereas for all other modes, as soon as the clock pulse is given, the count value is set. If the gate is set, it will automatically start the counter. The counter will start decrementing. Whereas for mode 1 and mode 5, only for the rising edge of the gate pulse, it will start the count value, right? And very importantly, this output signal, right? Only for mode 0, the output will be low initially, right? Whereas for all other modes, the output will be high, right? For all other modes, right? This is the very basic information that you have to know before understanding the operation modes of 8254, right? So for only for mode 1 and mode 5, gate signal will be acting as a trigger pulse. For all other modes, it will be set to 1, right? And output will be low only for mode 0 before starting the operation. For all other modes, it will be 1, right? Now we will see mode 0, right? So how mode 0 works? Mode 0 can also be called as interrupt on terminal count. So what is meant by interrupt on terminal count, right? It will create an interrupt as soon as the count becomes 0, right? That is why it is called as interrupt on terminal count. So if you see the logic, right, the mode 0 is typically used for even counting, right? And output will be initially low and it will remain low until the counter becomes 0, right? And as soon as the counter becomes 0, it will become high. And you can see here gate is equal to 1, it enables the counting, and gate is equal to 0 disables the counting. As I said before, for all the modes except mode 1 and mode 2, gate will be 1, only then the counter will work, right? So if you don't understand these lines, you can see this diagram. I'll explain the diagram so that you can easily understand, right? So now I'm going to explain the timing diagram of mode 0, right? So you can see here, this is the clock signal, a continuous clock signal, right? And you're going to give the count value. The count value will be given to the 8254 by enabling the write pin, right? So the count value is equal to 4. So you can see the count value is equal to 4, right? Now please understand very carefully, this clock signal and write signal is common for all the signals, even the gate, almost the gate also, right? So this two signal, clock and as well as write, it will be common for all the modes, right? That is, I'm giving the count value as 4, which means for these 3 cycles, 1, 2 and 3, for these 3 clock cycles, We are just loading the count value. We are just loading the count value. N is equal to 4 I have loaded, right? And as I said, for all the modes except mode 1 and mode 5, gate will be enabled. Gate will be high. Gate will be set to high. G is equal to 1, right? So you can see here from starting the gate will be 1, right? And now what is the output? What is the output? Now you can see here the gate is high and we have set the count. Like first 3 cycles it set the count. Here we have completed the setting the count, correct? The gate is also 1. Now the gate is 1, the count value is set. So what will happen? The counter will start decrementing the value, right? So for every clock pulse, right, it will start decrementing. The count value is 4. So from 4 it will decrement 4, 3, 2, 1, right? So all the 4 cycles, like it becomes 1, right? And you can see here till 4, 3, 2, 1 it is low, and as soon as it becomes 0, it is going to become 0, right? The output will go high, right? That is, after the count becomes 0, right, it becomes high, right? This is called mode 0, right? So I repeat it again. You can see here we have given the count as 4, right? So now it will decrement from 4. So 4, 3, 2, 1, and as soon as the count becomes 0, it is enabling it, the output will go high, right? That is, it will create the interrupt at the end of the terminal count. At the end of the terminal count. The end of the terminal count is this one, right? So this is called as mode 0. And now we will see mode 1. Now if you see mode 1 is called as hardware re-triggerable one-shot or hardware re-triggerable one-shot. As I said before, for mode 1 and mode 5 alone, gate pulse will be used as a trigger pulse. Gate pulse will be used as a trigger pulse, which means the counter will start only after the gate trigger, rising edge of the gate trigger. Now you see the clock pulse is same. For first 3 clock pulse, I have given the count value n is equal to 4, right? That is, we have loaded the count, and then the gate signal. The gate signal here will be acting as a trigger pulse. So you can see it is 1 here, right? And at one particular place, it creates a pulse, trigger pulse, right? And this is the rising edge of the trigger pulse. This is the rising edge of the trigger pulse. Only after the rising edge of the trigger pulse, the counter will start here. So you can see here, the counter will start. So at this particular cycle, you can see here, the counter, this is the rising edge. So at the end of this cycle, right, now what happens? The output will be high. Only for mode 0, the output will be low. For all other modes, output will be high. So till here, the output is high. And as soon as the trigger pulse, what happens? The rising edge of the trigger, what happens? It goes low and it waits until the count completes. That is, from 4, 3, 2, 1. Once the count is completed, what will happen? It will become high. It goes high, right? So you can see here, it becomes short pulse and it will remain low until the count reaches 0, right? So it completes the count, and until it reaches 0, it will wait and then it becomes high. This is mode 1, right? Whereas in mode 2, now you can see here mode 2, it is called as rate generator. Rate generator. Now you can see here, for all the modes, right? For all the modes, it will be high. Even in mode 2, it will be high. It will be high, right? Now, when the counting is enabled, same thing. I'm going to give clock signal, right? And I'm going to give count value, right? For first 3 cycles, I'm loading the count value, right? And mode 2, no trigger pulse, gate is set to high initially. So it will be set to high. So as soon as it is set to high, so as soon as the load count is loaded, from here the count starts, right? The timer starts, right? Now here, if you see here, the counter value is 4. So the output will be high from the initial stage. So it will be high. So it continues to high for 4, 3, 2, 1. That is, it will wait for this count, n minus 1 count, right? That is until it reaches 1, right? Now, when it reaches this n minus 1, it goes low and then it becomes high for one particular pulse. And this gets repeated for every 4, that is for every count value, for every 4 cycles, right? That is, before the end of the count, it will become low, right? It will become low for one clock cycle, right? This is called as a rate generator. Now you have to understand why it is called as rate generator. It works as a frequency divider. It works as a frequency divider, which means the value of count is equal to input frequency divided by output frequency. Input frequency divided by output frequency. Sir, what does it mean? Why it is called as rate generator? Right? So you can see here, if you see this particular cycle, right? This particular cycle, 1, 2, 3 and 4, right? If you say this particular cycle, the input cycle is 4, right? The input frequency is 4, right? The count value is 4. So what we have done is we have divided the input frequency, and whereas the output you have only one cycle. You have input, you have 4 cycles. You can see here for input you have 4 cycles, whereas for output you have only one cycle, right? So the input frequency is divided by the output frequency. That is the value of the count, right? So if you see here, right, the output frequency is equal to input frequency divided by the count value. You can also say that way, right? So that is why it is called as a rate generator. It calls as a frequency divider. You can see here you have 4 cycles. Here we have only one cycle, right? And now we'll see mode 3. Mode 3, once again, same condition. Gate will be enabled, right? Clock pulse, and then you will load, and the output will be high initially, right? Everything is same. You can see here. So the clock signal, right? And for first 3 clock signal, we will load the count. The count value is n is equal to 4. So from the gate value is already high. So as soon as we load the count, it will start from here, 4, right? 4, 3, 2, 1, right? And similarly 4, 3, 2, 1, right? Now you want to understand here, it generates a square wave in mode 3, right? So in mode 3, if it generates square wave, it depends upon the count value. If it depends upon the count value, that is, if n is equal to 4, that is even number. If n is equal to 4, then both on time and off time, that is on cycle and off cycle, right, of the square wave, it will be equal. That is, it will be n divided by 2 for both on cycle and off cycle, right? So you can see here now n is equal to 4. So what happens here? From here the counter starts. So it has to generate the square wave for first 2 cycles. That is, for 4 and 3, you will have a high input, and then for next 2 clock cycles, it is going low, right? So it generates square wave, and again it repeats, right? So for every even value, you will have equal T on and T off. Whereas if you have odd numbers, that is, say for example, if it is n is equal to 5, then what will happen is, for T on, we will calculate as n plus 1 divided by 2. That is, if it is 5, then it will be 6 divided by 2, you will have 3. And for T off, it will be n minus 1 divided by 2, which means 5 minus 1, 4 divided by 2. So it will be 2, which means for odd cycles, for if the count value is odd, then you will have one cycle extra in the T on, right? You will have one cycle extra in T on, and one will be lesser when compared to T off. Whereas if it is even, then it will be equally divided between T on and T off, right? So the concept is same. We are giving clock pulse and you are loading the count value through right signal, right? And as soon as the count is loaded, since the gate value is high, it starts generating the square wave generator. It will generate square wave depending upon this principle, this condition, right? If it is even, the count value is even, it will generate equal T on and T off. If it is odd, then what will happen? T on will be greater than 1 for T off, right? And now we'll see mode 4. Mode 4 we call it as software triggered strobe. Even here, what we are going to use, the gate signal will be 1, right? And you will give clock signal, you will give the right that is the count value in the through the right signal, right? And the output will be initially high. Same concept. You can see here the gate will be enabled, right? The counting will be enabled if gate is equal to 1, and if it is 0, the count will be disabled. Now you can see here, this is the clock pulse. For first 3 clock pulse, I am loading the count value, right? And the gate is already 1. So as soon as it reaches, right, as soon as the count value is loaded, the counter starts decrementing. 4, 3, 2, 1. Now you can see here, as soon as 1, once after all these things completed, it becomes low at 0. It becomes low at 0, right? That is for only one pulse, it goes 0. This is very similar to mode 2. This is very similar to mode 2. The only difference here is it is not sequential, right? It will go only one time, it will go low, right? And to get subsequent outputs, we have to reload the count again, right? But whereas in mode 2, it will create subsequent outputs. That is the only difference, right? So this is called software triggered strobe. And the last mode is mode 5, which is very similar to mode 4. The same operation, the only difference is the gate signal here is it is normally set high, but whereas in mode 5, it will be acting as a trigger pulse. So you can see here in mode 5, it is very similar to mode 4, except the gate signal is used as a trigger pulse, right? And the output will be initially high, right? And the counting will start only when the gate pulse is triggered. Now you can see here the clock pulse, and I have given the count value as n is equal to 4. We have loaded the count for first 3 clock pulse, and after that, right, it will not start decrementing. Why? Because gate is acting as a trigger pulse here. So it is wait till the rising edge of the trigger. You can see it rising edge of the trigger, right? This is the cycle where it ends, right? This is the rising edge of the trigger. So as soon as the rising edge of the trigger, the next clock cycle, it will start decrementing. It will start decrementing 4, 3, 2, 1, and then it goes low for one particular clock cycle. It is same like mode 0. The only operation here is it acts only after the trigger pulse. Whereas in mode 4, it will start from here itself. It will start from 4, 3, 2, 1 here itself, right? So this is 6 different modes of 8254, right? So you have to understand the basics about the operation modes. As I said, you have to understand how the input and gate pulse is given for each and every modes, right? How the modes are getting selected, right? So these 6 modes have different types of operation, and especially mode 2, mode 3 you will use for you will also do it as a practical experiment in your lab, right? So with this condition, that is for clock, gate, and as well as output, if you understand that condition, you can able to understand the timing diagram of operation modes 8254 very easily, right? So today what we have seen is we have seen the operation modes of 8254. I believe this video will be useful for you. Thank you, my dear students.